Hello, for this worked example video we are asked to find the sum of these two force vectors that are shown in 3D space. We're going to leave that sum in component form. So we've got two forces, F1 and F2, and the first step in adding these vectors is going to be to break them down into X, Y, and Z components. So let's start with F1. It's a little more complicated. It's kind of got a X, Y, and Z component. And so the overall magnitude is 600 pounds, and the direction is shown by these two vectors. And so I've got 30 degrees, I swing out in the XZ plane, and I go up from that 45 degrees. Alright, so I've got triangle, I'm going to call this one triangle 1, right here, and I'm going to have triangle 2 over here. And so I'm going to start with triangle 1 because I know the length of the hypotenuse of that triangle 1, and this piece down here is going to be a right angle as well as this piece over here. It doesn't look that way, but this is in 3D space, so what you imagine looking straight at that piece and looking straight down for the second triangle. So if I draw out my triangle, I kind of draw it over here. This is all for F1. This hypotenuse is going to be equal to 600 pounds. This component right here, this is entirely in the y direction, so that is the y component of my force vector, so that is F1y. And this piece down here, it's neither in the x or the z direction, but it's in the xz plane, so I'm going to call this one F1xz. And I know this angle, this is 45 degrees right there. So this is 45, and this is my right angle over here. Alright, so F1y, and look at that one first, is the opposite side of my right triangle. So this is going to be equal to the hypotenuse, 600, times the sine of 45 degrees, since it's the opposite side again. And that is 424.3 pounds. F1xz, down here, this piece is the adjacent side, so it is going to be equal to 600 times the cosine of 45 degrees, which is also 424.3 pounds. Alright, so we've got a start there. I still need to break this part. I know the y component, but I don't know x or z. I need to break this part down into x and z components. And so that's where triangle 2 comes into play. And so triangle 2 is kind of like this. This is fxz. This piece over here, this is in the z direction, so this is fz. And this piece over here is in the x direction, so that is fx. And this is all still for that F1 force vector. Alright, so F1x is going to be the hypotenuse, F1xz, so that is 424.3. And I need to know the angle. This angle over here is 30 degrees, and this piece right here, it's 90 degrees between the x and z components. Alright, so this F1x is the adjacent side on my triangle, and that is going to be the cosine of that angle. So 424.3 times the cosine of 30 degrees. And that is 367.4 pounds. And F1z, that is the opposite side. So it again is the hypotenuse, which is 424.3, but this time it's times the sine of 30 degrees. And that is to 12.1 pounds. Alright, so now I have the x, y, and z components of that F1 vector. At this point, it's usually good to double check to make sure that the signs are correct. And so it looks like it's positive in the x direction, positive in the y direction, and positive in the z direction for all three of these. So what I have written will be correct there. Alright, so now I've got x, y, and z for my F1 vector. I need to do the same for my F2 vector. And this one, it's a little bit simpler because I've got no x component. And so this triangle right here, I'm going up 40 degrees from the z-axis. And so I'm going to have a y and a z component here. Alright, so drawing my triangle, it's going to look kind of like this. And it's 3D, but this is actually a right triangle. And so y and z are 90 degrees from one another, and that angle there is given as 40 degrees. Alright, so if this hypotenuse is the magnitude of the vector, this is 300 pounds. The vertical part of this is going to be F2y, and the horizontal part of this is in the z direction. This is F2z. Alright, so F2y is going to be the hypotenuse, so 300 pounds, and is the opposite side, so it's the sine of 40 degrees. Alright, that gives me 192.8 pounds. And for the z component, F2z, it is the adjacent side, so again it's the hypotenuse, which is 300 pounds, but this time it's times the cosine of 40 degrees. And that is going to be 229.8 pounds. Alright, now I simply need to add up all of the x components, all of the y components, and all of the z components. So, fx is going to be f1x plus f2x, and that is f1x was 367.4 pounds, and f2x was actually equal to 0. It had no x component. So fx total is simply 367.4 pounds. Alright, fy, can add up all those y components, is going to be the y component of force 1 was 424.3 pounds, and the y component of force 2 was 192.8 pounds. And so that total is 617.1 pounds. In the z direction, I need to add up the z component of force 1 and the z component of force 2. That is the z component of force 1 was 212.1, and the z component of force 2 was 229.8. So that gives me a total value of 441.9 pounds. Alright, so this is the x, y, and z component of my sum. If I want to write that out as a total or net force, is going to be 367.4, 617.4, or 0.1, sorry, and 441.9. or the X, Y, and Z components in the units, I need to label as pounds. So this is the sum of those two force vectors that I had in my original diagram here. So with that, thank you for watching, and I hope to see you again.